So, what in the world is a recording PC, I hear you ask? Well, when I stream on Twitch, my gaming PC broadcasts 1440p video on the network, and the streaming PC captures it and downscales it to 1080p before being sent over to Twitch. Seeing as the gaming PC is broadcasting that 1440p on the network, I could use another PC to capture it and record it at its native resolution. This means I can get better quality footage instead of downloading the 1080p Twitch VODs. Now, as I'm editing this video, Twitch is currently trialing 1440p streaming. So what's the point, I hear you ask? Well, I built this recording PC 5 months ago before this was a thing, but there's more to it than you think. I want to use my captured footage in my Satisfactory 1.0 tutorial series to update my Satisfactory Guru website. If I'm using Twitch VODs, it's not possible to separate my camera overlay and other things like viewer-triggered sounds and effects. So, join me in this journey of discovery while I learn what does and doesn't work and see where it almost comes apart right as I get started. First up is the case I'm going to be using. It's a very old rack case that would most likely be at least 30 years old. I came into possession of it in the early 2000s and eventually it housed one of my old homebrew ESX servers. It has a 4 by 2.5 inch SATA hard drive cage that fits into one 5.25 inch drive slot. I won't be using it in this build here, but it's a handy accessory nonetheless. You can see the old motherboard here is a Gigabyte GA F2A85X UP4. It has an AMD A10 5800K 4-core 3.8 GHz CPU and 32 GB of DDR3 memory. I'll probably do a video about this sometime in the future, but for now it's time to take it out so I can repurpose the case. It's also time to remove the old fan from the front. I'll replace that shortly with a newer one. Just so you know, this case is smaller than the other rack cases I've got, but it's much heavier. It's made from a thicker steel. The replacement fan is a Phanteks SK 120mm PWM fan. As to the power supply, don't worry, it's not the original power supply that came with the case. I did replace it some years ago, probably in 2013 when I installed that last motherboard. Seeing as it's not broken, then I'm not going to replace it. If anything does happen, I do have spares to use in a pinch. Anyway, so what kind of computer am I building? Well, some time ago my streaming PC had this Intel i5 9600KF 6-core processor, before I upgraded it to an i9 990K. Since then, I've had this i5 9600KF sitting in a box doing nothing. This requires DDR4 memory, and the availability of getting a new LGA 1151 motherboard and DDR4 memory is going to become harder and harder. I managed to find this new in box Gigabyte B365M D3H motherboard on eBay. So once I committed to buying this, I also purchased a Deepcool AK400 Zero Dark CPU cooler. I've had this Noctua NT-H1 thermal paste in my spare supplies, so no purchase is required here. For storage, I bought this Crucial 2TB PCI 3.0 NVMe SSD, and for memory, I bought 2 sticks of G.Skill AGS 16GB DDR4 memory. My GPU is an older Asus GTX 1660 Ti, which has the NVIDIA hardware encoding chip. Very useful for OBS. Now we know what we're working with, let's get the build underway. First up is to install the NVMe SSD in the motherboard, which is pretty straightforward. Next up, it's time to install the CPU into the socket, and this is when I discover that this new in-box motherboard isn't that new. Once I remove the CPU socket cover, I can instantly see bent pins. So no, it's definitely not new in box. Before proceeding, I take a few photos as I may still return it to the seller. But I also know if the pins can be bent back, then it should still work okay. It's not like it's the end of the world. In this photo, you can see 2 pins that are bent. And then in these photos, there is another pin that needs to be adjusted. And then here's the nail in the coffin. Look at this build-up of dust and hair. This clearly isn't new in box. So I pulled out my craft knife and I used one hand to hold my phone that zoomed in. It makes it much easier to see what I'm doing. This is still not a straightforward job, but after about 20 minutes I think I've done enough. I don't want to stress the pins too much and then snap them off. I dropped the CPU into the socket and it seemed okay, so let's keep going. At the same time, let's get that 32GB of RAM installed. Now, because of the uncertainty of the bent pin situation, I'm not going to install it into the case straight away. Instead, I'm using this test frame I bought on AliExpress a while ago. This is my first time using it. It works pretty well, and I plan on doing a video on this later down the track, so keep an eye out for that one. With the motherboard mounted, I install the GTX 1660 Ti into the PCI X16 slot, as this is a KF series CPU and hence it doesn't have onboard graphics. I pull out a spare power supply and install it on the test frame. The test frame also came with this handy power switch I can connect to the motherboard header for turning it on and off. Very useful indeed. I plug in the power cables for the motherboard and GPU and we're almost ready to turn it on. With the display cable and keyboard connected, I tried turning it on and nothing seemed to be happening. Not a good sign. I double checked all the connections and still nothing. Seeing as this wasn't a new in-box motherboard, I suspected there might be a BIOS setting for another CPU that could be preventing it from booting. So I used a screwdriver to short the clear BIOS pins and the motherboard jumped to life. Success! After checking in the BIOS that the CPU had been correctly identified, I felt a weight lift off my shoulders. It looks like this motherboard is going to be okay to use. So with that out of the way, let's mount the CPU cooler onto the motherboard. The test frame comes in handy here again, as I can easily access the back of the motherboard to put the mounting backplate in place. I realised at this point it was probably a good time to brush away the dust that I spotted earlier before putting the other side of the mounting plate in place and screwing it down. It's time to apply the thermal compound. The back of the box has a handy guide explaining how much to use. Armed with this knowledge, I applied the exact amount of required compound and then put the CPU cooler in place and screwed it down. I tried clipping the fan onto the CPU cooler, however the GPU was kind of in the way, so I removed it first. This made installing the fan much easier, so after connecting the fan to the motherboard header, I reinstalled the GPU ready for another test. I booted it up again and it all seemed fine. I even booted into a live Linux distro and it seemed to be running fine. So with the initial testing phase out of the way, I disassemble the components from the testing frame and mount them into the rack case. This was very straightforward except for one thing I didn't count on. The CPU cooler is taller than the height of the case. Dope! Honestly, this isn't a big deal. The case is going to be mounted in the rack and the work it's doing isn't going to be impacted by not having a lid on. The only thing I didn't cover earlier was networking. While this motherboard does have onboard 1GB, I have a spare TP-Link TX201 2.5GB PCIe network adapter which I installed into the spare slot next to the GPU. With all the building done, I proceeded to go and place it in the rack, and for the time being it's just going to be sitting on top of the UPS. It booted up fine and I proceeded to install Windows 10 on it. I might upgrade to Windows 11 later. I think it needs a TPS 2.0 module to do that, but I'm not worried about it right now. I decided to run some benchmarks on the system to stress test it a bit and see how the CPU cooler performs. Everything seemed stable and the most I could see it peak at was 72 degrees Celsius, so that's fine by me. At this point, the recording PC only needs one cable connected for it to operate, and that's the network cable. When I turn it on, I simply remote desktop into it from the streaming PC. Now that I've got a working PC, how exactly is this going to work as a recording PC? DistroAV makes a plugin for OBS called NDI, which means Network Device Interface. This allows you to select a source in OBS and broadcast that across the network. This is how my gaming PC currently sends its signal to the streaming PC at 1440p. Now on the streaming PC, it downscales this to 1080p and adds overlays to it. So if I was to record that from OBS while I was streaming, then everything is going to be captured together. There's no way to separate the webcam from the game footage and the game audio from the stream alerts.
Thank you Morgant1C for renewing your tier 1 sub of 42 months.
This is where the recording PC comes in. I install OBS on it, add a source, and select the gaming PC NDI as the source. Now I can record that raw game footage and audio at 1440p. But that doesn't capture my camera, microphone and stream alerts. How am I going to capture that? So on the recording PC, I run another instance of OBS in portable mode. This allows me to add a video source from the streaming PC that is of my camera. Now on the streaming PC, I need to go to the scene for the camera and add a filter. This is a dedicated NDI output of this scene. With that defined, this can be added as a video source on the recording PC. I also add a green background source here, as this is how I can crop myself in video editing later on. For my microphone, I need to do the same on the streaming PC. I add a dedicated NDI output filter to the microphone in the audio mixer, and then on the recording PC, add that as an NDI audio source. Now, for one more layer of complexity, I also want to capture the stream alerts, like when a follow happens or a funny sound effect is played. This is all generated on my streaming PC by Firebot, and the way this is presented to OBS is via a web page overlay. On the recording PC, I create a browser source that points to that Firebot URL, and now that is also captured in this recording. This, however, does combine the audio of the microphone and the alerts into one audio track. To separate this, I go into the advanced audio properties of the audio mixer and assign the microphone source to track 1 and the Firebot source to track 2. This will now create separate audio tracks in the recording file, and the video editing software allows me to separate these out. It's pretty awesome. Because I'm running two instances of OBS on the recording PC, instead of installing OBS, I'm using the zip download of OBS and creating separate directories for each instance, one for gaming and one for camera. I run both of them in portable mode, and this keeps the configurations separate and less complicated. An advanced topic I'll briefly touch on here is that I have separate network socket ports defined for the WebSocket server settings in each OBS instance on the recording PC. This lets me control these instances from the streaming PC. I use a program that allows me to start the recording of both instances at the same time, so the two recordings are aligned with each other. It also allows me to do things like mute the audio sources when I have a stream break, which makes finding that in editing much easier. I hope you enjoyed this behind the scenes video of how I built my recording PC and turned my setup into a 3 PC setup. Was it worth it? Absolutely. I'm much happy with the quality of the videos I upload to YouTube of my streams, and also how I can use that same gaming footage for other videos as I update my Satisfactory Guru website. I don't need to go and record dedicated footage. If there's enough demand, I may even produce another video that goes into more detail in how to get this setup running from scratch. You let me know in the comments below if this is something you're interested in. Well, that's all from me now. I look forward to seeing you in a future video. Bye!